So this is our last unit of semester 1. We are going to be looking at something called conic sections. Now there are 4 types of conic sections that we are going to learn. There's going to be what's the parabola, a shape of a graph you've already learned. We're going to look at it in a different context. The circle, another graph at it in a different context, and then 2 new ones, the ellipse and the hyperbola. They get their names because they all look like slices of a cone. Like if you cut a cone diagonally, that shape of the cross section is going to form a parabola. If you cut a cone completely horizontal, parallel to the base, that's going to create a circle. If you cut it diagonally, but it doesn't go through completely, we're going to have an ellipse, which is basically like an oval, but a very particular type of oval. And then the hyperbola is when you cut 2 cones completely perpendicular to the base, forming what looks like 2 parabolas, but the bend is going to be slightly different. We're going to focus on first circles as kind of a review of some stuff you already should know, and then we're going to move to the parabola, and then we'll finally look at the ellipse and the hyperbola. There will be no test this unit. We're just going to have one assessment that's going to count as a quiz after we learn these 4. We're not going to look at the trig too much with these. The trig is going to come back into play second semester when we look at what's called polar graphs. So these are graphs we need to understand now for when we look at them again second semester. So the first one we're going to look at is a circle. All of this should be a review from what you learned during geometry. So we know that a circle is the set of all points from a fixed point. That fixed point is, of course, called the center. The distance between the center and a point on the circle is called the radius, and we know those words already. The standard form, we're going to use h comma k as the center, where the radius, we're going to use the variable r, and that standard form, we're going to have x minus h squared plus y minus k squared is equal to r squared. Do want to talk about this formula. It actually does come from the Pythagorean theorem. Like we know that theorem shows up a lot over and over in math. Like we know it just for right triangles. We saw the Pythagorean identities. Where it's coming from any circle again, this distance from this side is going to be x minus the h. This distance is going to be the y coordinate minus the y. And we know from the Pythagorean theorem, leg squared plus leg squared is equal to r squared. So we do see that this really is just a different form of the Pythagorean theorem. Things that we should already know how to do. We should already know how to write the equation of a circle when given certain characteristics. So for example, if I just say this is centered at 0, 0, pretty easy one. So we have x minus 0 squared plus y minus 0 squared is equal to 8 squared. That's the radius squared. Often we'll just write this as x squared plus y squared is equal to 64. Same thing for this other one we can do pretty quickly. We're still centering at 0, 0, so I'm just going to go ahead and write x squared plus y squared is equal to r squared. Mainly chose this one to remind ourselves some of the algebra we use for squaring that. 5 squared is 25. The square root of 2 squared is 2, so that would be equal to 50. Again, this is the graph of a circle. In math, we call these implicitly defined functions, or really not functions, but curves, because they are not in the form of y equals or f of x equals. The x's and y's are mixed together on the same side of the equal sign, which is something that we explore in calculus. Another type of problem we can write, we have write the equation of a circle that passes through negative 2, 5, whose center is at 3, 3. What are we missing? We're basically trying to find what that radius is. We don't know what it is. So how do we find it? We basically want to find the distance from the center to that point. We do have the distance formula, like we've learned that before. The distance formula, again, is just another way of writing the Pythagorean theorem. And in fact, the distance formula is the circle formula in disguise. Like if you square both sides, you end up with d squared. Well, what is that distance for a circle? It's really just the radius. And I'm going to go ahead and plug in what I have. So this one is centered at 3, 3. and it's going through the point of -2, 5. Solving for that radius, -2 minus 3 squared, that's -5 squared. 5 minus 3 is 2 squared. So we see that the radius is the square root of 29. So what is the equation of that circle? So I have x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center squared is equal to r squared. Well, the square root of 29 squared is 29. Graphing circles is another skill that you've learned to do. And again, when you're graphing a circle, two things you need to find. You need to find the center and you need to find the radius. I like putting it into the standard form. So I have x squared plus y squared is equal to 16. That 16 tells me my r value is 4. H and k is 0, so it's centered at 0, 0, and the radius is 4. So this circle will look something like that. Looking at number 5, this isn't quite in standard form, but I can divide everything by 6. So I have x squared plus y squared is equal to 9. That 9 tells me that my radius is 3. Centered at the origin, this circle looks something like that. Now we know that the center is not always at the origin, but we would follow a similar process. To introduce some vocabulary, and again, this is stuff I hope you remember. If not, this is your reminder. We talked about the standard form of the equation of a circle as well. We also have the general form of the equation of a circle. And in fact, we will find the general form for all conic sections. Basically, when you're looking at the general form, there's like no parentheses and everything is going to be equal to 0. Things we want to be able to do is to be able to convert back and forth between standard and general form. So I have a circle is centered at 3, 2 and has a radius of 5. So in standard form, we have x minus 3 squared plus y minus 2 squared is equal to the radius squared. 5 squared is 25. If I want to convert this from standard form into general form, we just need to FOIL, combine like terms, and then make sure we get it equal to 0. And that just is going to be some algebra. Not too tedious, but just some algebra to do. So squaring the x's, x squared minus 6x plus 9, squaring y minus 2, y squared minus 4y plus 4 equal to 25. And then I want to kind of rearrange this and get it equal to 0. So I have the x squared and the y squared minus a 6x minus a 4y. And then I have a positive 9 plus 4 subtracting the 25. 9 plus 4 minus 25 is going to give me negative 12, and this is equal to 0. So that would be this same circle where we've taken it from standard form to its generalized form. So that brings us to the last topic I'm going to look at is, well, how do we go from standard form back into general form? Well, what process will we need to go through? We are going to need to complete the square, which hopefully is not giving you any anxiety. Like, I think completing the square is often made a lot more difficult than it really needs to be. The idea behind completing the square is you are going to force perfect square trinomials to show up. Main idea with completing the square is we're going to add b over 2, where b is a coefficient of the linear term, and making sure we balance out the equation. So again, I'm not going to make this more complicated than it needs to be. Here is an equation of a circle in general form. I know it's a circle because I have x squared and y squared in the problem. And the first thing I do is I group my x's and y's together and then move the constant to the other side of the equation. So I have x squared plus 4x. I'm going to leave a little gap. I have the y squared minus 8y, leave a little gap. That plus 4 is moving to the other side as negative 4. That b value is what you see in front of the linear term. So the b value of the x is a 4. So I'm going to add that 4 over 2 squared. But what I do to one side of an equation, I have to balance it by adding it to the other side of the equation. And then I want to add the b value to the y on the other side. So I have minus 8y. So plus negative 8 over 2 squared, making sure I balance it, negative 8 over 2 squared. Rewriting that, we have x squared plus 4x. 4 divided by 2 is 2. 2 squared is 4. Then for the y's, y squared minus 8y. Negative 8 divided by 2 is negative 4. Squared is positive 16. And on the other side, I'm adding negative 4 plus that 4 plus the 16. Again, we want to make sure we balance it. How do we factor it? We're going to look at those trinomials together. How does x squared plus 4x plus 4 factor? That's going to be an x plus 2 times an x plus 2, or the shortcut, x plus 2 squared. Y minus, what times what is 16, and add to give you negative 8. Well, that will be a 4. And equal to on the other side, adding those together is going to give you 16. How is that useful? We now know that the center of this circle is at negative 2 comma positive 4. Remember, it's going to be the opposite sign here. And the radius, the square root of 16, is 4. Now it will be much easier to graph. So some shortcuts. The sign you see in front of the b value tells you the sign you're going to have inside your binomial. And then that b value over 2, kind of just looking at the number, not really the sign of it, that will tell you what goes inside the parentheses as well. Go ahead and pause the video and rewrite these into first general form and then complete the square. I'm going to start working on them, but again, I hope you pause them, try it yourself, and then check your answer with mine. So I rearranged it, I grouped my y's together, I grouped my x's together, then I balanced it, adding that b over 2 squared to both sides for both variables. And then I'm not going to do the shortcut when it comes to factoring it. This is going to become x plus 12 squared plus y plus 3 squared equals 2. This is a negative 137 plus a 144 plus a 9, which is going to give me 16. So that's the standard form with the center at negative 12, negative 3, and a radius of 4. For the second one, I'm going to work below just so I have a little bit more space. I have the x squared plus the 8x, leaving a gap. Y squared minus 2y, leaving a gap, equal to 64. And then I can go ahead and complete the square. So plus 8 over 2 squared plus negative 2 over 2 squared, making sure I keep my equation balanced. So I get x plus 4 squared plus y minus 1 squared is equal to, my constants, I have a 64 plus 8 divided by 2 is 4, squared is 16, plus a 1. And then I can just add those together to find my radius. 64 plus the 16 plus 1 is an 81. So the radius is 9, and my center of the circle is negative 4, comma 1. Now your homework, please don't do this on the note side. Please do this on the homework tab. But it's just questions 3, 4, and 5. And there's my dog barking. and then question number 6.